Okay, welcome back. So we're just going to continue trying to fill these in and show you how we derive these trigonomic identities. So we're going to start off with an equilateral triangle this time. Okay, I mean this is why it's so absurd for me, to know that you can. We've used an isosceles triangle and how that's come into play. You learn it as a kid. You're like, well, what's the point of this? And then you sort of, when you get to the end point, you realise how important these triangles are. It's like, well, why didn't you show it in the first place? But then it's because you need so many skills to kind of build up to know. I was dazzled when I was sort of first shown this. So, you can't get all the way to the top of the mountain. You have to climb it step by step. But anyway, so I'm going to draw or attempt to draw an equilateral triangle. I didn't want to draw it there, and I didn't want to use that colour. So do that in white. Okay, and we'll just do. Let's have a look. So okay, and well, boy, this is hard to draw. Do an equilateral triangle using a ruler. Oh dear, that's not going quite right. And that is surely not an equilateral triangle. Okay, that's as close as I'm going to get using the utensils I have. Okay, so what are the properties of an equilateral triangle? This is what makes you need to know these properties to basically take the next step and the next step to deriving what we want to derive. So, firstly, we need to know that all sides of an equilateral triangle are equal. Okay, that's a property we need to understand, and in fact, that's the most important property. Actually, we also need to understand that all the angles are of equal or are equal. Okay, so 180 degrees in a triangle. So we have three angles, therefore every angle is 60 degrees. Okay, I'm just going to write it out so you can see. So they're the properties of an equilateral triangle. I'm not going to just list them. We can see three sides are the same, three angles are the same. So let's try and derive our sine 30. Where do you start? So someone he came along and he drew this triangle, and he just sort of, it took him down a path, and he thought, well, let's make these lengths 2. Let's just choose the number 2, and we'll see the logic behind why the person chose chose the length 2. Okay, so that's very sexist. It could have been a woman. Then chopped the triangle in half. Okay, and ignored this half to some degree. We'll see this in a second. So now we'll make this angle 30 because we've chopped it in half. So therefore the angle isn't 60 anymore. It's 30. So I hope that's okay. So now we've got, and we also know that it's 30 because if we add 90 plus 60, it's another way to that's like 150. So that's got to be 30. 180 minus whatever difference, you can work it out. So carrying on, we will then we can actually, this length here, we want to, we're not dealing with this length, so we need to find out what this length here is now. And it's 1 because it's half of this length, right? So it's pretty simple, and that's why we chose 2, because it's really easy to then see that this is going to be 1, so we can just get rid of the 2 and get rid of that. We don't need that. So now we've got half of an equilateral triangle, and now it's just a case of let's working through. So let's pick sine. We wanted sine 30, didn't we? So let's just do that, and it's sine 30 is so, right? Opposite over hypotenuse, so the opposite of 30 is 1, and the hypotenuse of this is 2. So sine 30 equals a half. So let's go and fill that in our little box. Sine 30. Let's use blue. I mean, there's no need to change colours, but it's just to show you, you know, that we sort of take it angle by angle. So let's find what's next on our list. Cos. Let's find the cos. Go to white. That's right, red. Right. So let's do. No, I've gone. Why is it? I have to edit this. Right, red. Cos 30. Right. Ka. Adjacent and hypotenuse. I'd go with the hypotenuse, which is denominator. So cos 30. The hypotenuse is 2. And well, let's see, what is the adjacent? Well, in actual fact, we have not worked out this length, and we need the length now. So how are we going to do that? Pythag, of course, and we know that that's a squared plus b squared equals c squared, right? We have to note that this is the hypotenuse. Okay, so I mean, it doesn't matter which order you do these in, but you have to realise that that is always the hypotenuse. So just I haven't experimented, and I don't know whether it would make a difference yet. But let's just go with that for now, because I'm pretty sure that if we work out the hypotenuse, that is the hypotenuse, then we're going to be safe and dry. So we want this angle, but we only know the hypotenuse. So let's say that that's the C, and well, we know the opposite. Well, actually, as I say, it doesn't matter which one you choose. So let's just say that that's b squared, and we don't know a squared. So what we're saying is we don't know that that's a. So let's just go through the motions. So that'll be a 4. That's just 1, isn't it? Right. So you've got a plus 1. Right. Taking 1 away from both sides, you then get 3. So we now know that. Oh, hold on, we haven't squared it. So the net we missed out for quite an important phase. So we know that a equals the square root of 3. So we'll just get rid of that. Square root of 3. I hope that's visible. Very messy all this. Yeah, so we wanted the adjacent. Coincidentally, we called it A. That was just sheer fluke, and just stick that there. So now we know that the cos of 30 is square root of 3 over 2. So let's be very chuffed with ourselves and write that in. Cos 3 over 2. Okay, slightly different shade of blue, but never mind. So let's do the tan. Doing a green. So we want tan 30. And what's tan? It's SOHCAHTOA. So we want the opposite, which is 1, and we want the adjacent, which is square root of 3, and we know that we want that on the top. Convention. So if you want to write it out explicitly again, I mean, if you didn't get it first time round, that is a multiplication sign, and so we're just timesing that like that, and to give us the square root of 3 over 3. Some people might look at this and think, you know, why are you timesing top and bottom by this to get the, you know, how does that work? But it's just a case of, you know, if you're doing say a half, and I wanted to, it's to keep everything balanced, you see. You know, if I just times, say, the bottom by 2, then then you've got that equals a quarter. But if I times the top and bottom by 2, right, that means I've got right down here. So that means I've got 2. You know, 1 times 2 is 2. 2 times 2 is 4, and that equals a half. So I've just, which is what we had in the first place. So that's why, that's what's going on over here. And there's our answer: square root of 3 over 3. And we'll leave it as that for this video. Square root of 3 over 3. And I think that's enough work for this video, and we're just going to run through the sine, cos, tan 60 for the next video. See you there. Exciting stuff.